Hello, my name is Christopher Chappie. I work at RLC Engineering. This is part two of a three-part series on how we're using AI at RLC to make new tools, improve our tools. This video is going to focus on improving our tools. In the previous video, we made a tool, a Python code, which had a 10-volt DC source and five 1 ohm resistors. And that found the voltage drop across each resistor and actually the voltage at each node in the circuit. But something a little bit more realistic and a little bit more complex is not each resistor or conductor has the same impedance. So in this new example, we're going to double the impedance of the previous resistor. So it'll go from 1 to 2 to 4 and so on. And this is a little bit more representative of the type of impedances you'll have in a wind farm where they're not all the same, they can be different. So let's look at that. I'll put the prompt in to improve our code, and it's going to spit out some code here. And we can copy this code and bring up our Python shell. And let's get that in there. And let's see what the result looks like. So we're using AI at RLC to make more and more complex code. And here's the output of that, where it prints the resistor values. It prints the voltage drop across each resistor. It's important to note that the voltage drop is doubling each time. And this makes sense because the resistor values are doubling each time. And then it also shows the voltage at each node. One thing to note is Python is somewhat numerically limited. So this doesn't say 0, but something times 10 to the negative 16th is essentially 0 volts. So we were able to make a much more complex code from something that we already have and get it working. And we're doing this at RLC, improving our processes, improving the tools we already have using AI.